So let's look at a couple more examples of evaluating radical expressions. So let's just rewrite this. We have 3 to the 1/5 divided by the fifth root of minus 96. And since this is raised to a fractional exponent, let's also convert this to a fractional exponent as well. Since we know that the fifth root is really just whatever this is raised to the 1/5 power. So we have minus 96 raised to the 1/5 power, and we have a quotient here. So remember that when you have a quotient raised to the same exponent, so let's say you have a to the x divided by b to the x, that you can rewrite this as a quotient of the bases a divided by b, all raised to that x power. So since these have the same exponent, we can rewrite this as a quotient of the two bases, so 3 over negative 96, and then all of that is raised to the 1/5 power. Now, 3 and 96, they're both divisible by 3, so we can divide top and bottom by 3, and so we get 1 up top, and 96 divided by 3 is 32, but we still have our negative sign, and all of this is raised to the 1/5 power. Now we can essentially just apply this rule in reverse. So now we have a quotient and we have this raised to the x power, or the 1/5 power here. So we can take the numerator and denominator of this quotient and raise that to the 1/5 power. So we have 1 raised to the 1/5 power and minus 32 raised to the 1/5 power. So we're taking a fifth root of 1, and really 1 raised to any power is going to be 1, so the numerator is 1, and we're taking a fifth root of minus 32. So what number multiplied by itself 5 times would give us negative 32? And since it's a negative number, we know that whatever the answer is, that should be negative. And so what number multiplied by itself 5 times gives us 32? Well, 2 to the 5th power is 32. So we get minus 2 in our denominator. So our final answer here would be minus 1/2. And again, with these problems, you want to get in the habit of checking these with a calculator. And I would just recommend rewriting them with their fractional bases. And when you put these in, make sure to put the exponents in parentheses if you don't have one of the newest graphing calculators. And that way you can just protect yourself against making mistakes with order of operations. So let's do one final question. And with this one, it looks like we have a product, but the bases are the same. So this one's a little bit different than the ones we've done before. If we have two exponential expressions multiplied together that have the same base, but different exponents, remember that we can just add the exponents and make it into one exponential expression. So x to the a times x to the b is really just x to the a plus b. So let's rewrite this. So we have 1 over 81 raised to the 1/2. And again, we're just noticing that the base is the same, so we will be able to add these exponents. So combining it into one expression, we have 1 over 81, and it will be to the 1/2 power plus minus 3/4. And since we're adding and subtracting fractions here, let's give them a common denominator. We'll make this 2/4. And we're adding minus 3/4, so just subtracting 3/4. So simplifying, this is 1 over 81 raised to the minus 1/4 power. Now we have a negative exponent. So remember that if we have a quotient raised to some negative power, that we can essentially just take the reciprocal of that quotient, b over a in this case, and raise it to the positive version of that power. And this rule is a bit tricky to remember and to think about why. But remember that a negative exponent just means that we're dividing repeatedly, or we're dividing x amount of times here. So we really have 1 over a over b to the x power. We're dividing by this expression here, this quotient, x times. So remember, just the negative for an exponent just indicates repeated division. And then, of course, when we are dividing by a fraction, it's the same thing as multiplying by this fraction flipped over. So that's how you get your b over a raised to the x power. So when we have a negative exponent, we can just essentially flip the fraction. So let's do that. This is just 81 over 1 raised to the 1/4 power. And raising something to the 1/4 power is the same thing as taking the 4th root. So what number multiplied by itself 4 times would give us 81? And that would be 3. Since if you multiply 3 by itself 4 different times, you do get back 81. And I will leave it as an exercise. You can check this using your calculator.